Let's talk today about constructors in object-oriented programming. And I will try to give a few, actually 4 ideas, 4 thoughts about how they should be designed and what principles we should have in mind when using constructors. I'll try to start with a practical example just to make it easier to understand and make it shorter. So here's a simple object, a simple class, which is called web page. And as you see, there is only one constructor which accepts only one argument, which is the actual address of a web page. And then this address is being encapsulated into the object. And then the object has a method content, which actually returns the content of a web page. In order to get the content, we create a new object inside the method content, which actually is a transport protocol or the actual engine which goes to the web and downloads the page. Then we call the method fetch, which is attached to arguments. The first one is what's the method, what's the HTTP method, and then the address of a page. So we do it like this. The first idea which I would like to suggest to use, the first principle related to constructors in OOP, is that the operator new, this one, should not be used anywhere else except the constructor. So every time you see the operator new inside the methods, not in the constructor, but inside the methods of an object, it means that there's something wrong and it's better to refactor the object, to refactor the class. So this is the I think this kind of extreme approach, but if you try to follow it and try to keep this in mind, I think the design will be improved and will just look better and better. So again, the constructor is the only place where the operator new can be used. So in order to refactor this class, we will have to add a new argument to the constructor, which we will call, for example, HTTP, and we call it transport. And then we create a private property here, let's say HTTP, and then we have HTTP here, transport, and then we replace this with this HTTP. Now we don't have operator new at all, and because we just removed it from the content. And then if we want to have the operator new, then we remove it from here, and then we say new Apache, whatever, transport. Now, as you see, we have 2 constructors, and the second constructor accepts the custom instance of this HTTP abstraction, HTTP class, and we have another constructor, which we had before, which accepts the, actually this one, we can remove for now. So we just accept, like we did before, we accept the address, and then we use operator new in the constructor to create a transport, which will be used inside the method. That's the idea. So when new operator was present in the method, it was something wrong. It's a bad design. Why? Mostly because there is not possible to do dependency injection, and it's not possible to customize this object. So the object is hard-codedly, it's the dependency, the transport is hard-coded. It's really hard. It's really like is strictly linked to the web page class. So it's not possible to replace it anyhow. At the same time, when we have new operator in the constructor, it's possible to use more constructors and to use this mechanism of constructing objects for actually injecting this dependency into the object. So the first principle: no new operators inside constructors, inside functions, inside methods, only in constructors. If you follow this principle, the objects will be way more configurable and way more flexible to use. Of course, it's not possible always. Sometimes you just have to use new operator. For example, I don't know, you can do something like, I don't know, there are many, the object may depend on many other objects, on many other classes. And we may need to have new something here, I don't know, some primitive classes, maybe, I don't know, new file, something, maybe not a file, but some small, some micro objects, you may still need to use new operator, but try to get rid of that. Try to make sure that only constructors, only here, you actually use the operator new. That's how you make your object's dependency injection ready in the first place. Even though maybe you don't need this, maybe you don't need to inject this custom instance of the HTTP class, but this design is ready for injection. It's ready for testing. It's ready for, it's really flexible. It's ready for, it's testable. It's ready for being used in a different way, in really different flexible ways. Even at the same time, if we have new here, then this dependency is just here forever. And nobody, no users of this class can actually replace this Apache transfer with something else, with maybe for example, like fake transfer, which doesn't really go to HTTP, doesn't make any HTTP requests, but retrieves files from, retrieves the content, maybe from nothing, from memory, or maybe this one, file transfer, or maybe something else. While in this case, it's perfectly configurable. And how we did that? We just enforced the principle. The new operator should not exist here in an ideal scenario. That's the first principle. The second one about constructors, I think that every class, every object has to contain as many constructors as possible. So the more constructors you have, the better is the design of your class, and the more flexible it is, the more reusable it is for its customers, for its clients. In this case, we have two constructors, but we may create more of them. We may create, for example, this one. We may say, okay, you can provide a string, you can provide a URL, and then in this case, we'll put like this. And then we may create another one, which, if you like, you can provide another instance, for example, URI. And we may create another constructor which will say, okay, if you want us to get your content, for example, from a static file, so it's always going to be the same. I'm just improvising. So, for example, the file is here, and then we create the transport, which will be new file transport, for example. Which will not really go to HTTP, but will just make a call to a specific file and always retrieve what's in the file. And we may create more constructors. So the more constructors we have, the better, the more suitable, the easier this class is to use for different clients. And the question is, I'll show you what exactly is, what exactly we are improving here, what's happening. So if we have multiple constructors, more and more and more, so we create them as we need them, then later, here's how we can use this class. So again, I'm trying to explain why more constructors is better than less. Because it actually saves, it actually helps us to get rid of code duplication. Let's look at these examples. For example, we have, we say, we make an instance here, and then we make an instance here. This is an instance which, which is a web page which represents this address, and we can get its content. And then it's another web page which represents another actual web page somewhere, and we also can get its content. The difference here is only in the address. But the second argument, which is Apache, HTTP, whatever, is actually identical in the first case and the second case. So we can move it out and say, okay, this is our HTTP, and then we can put HTTP here and HTTP here. But it's okay in this case. But what if we have somewhere else something similar, and in another place of a code, in another class, another file, we still again need to instantiate this object with the same set of arguments? We can possibly transfer an instance, this instance, like it's done in dependency injection. For example, we can put this stuff into dependency injection container and then get it out of the container every time we need it. But in that case, we need to pass this dependency injection container everywhere, which is not also really quite convenient. And I'm in general against this dependency injection containers. So it's way better to put this default instance of the transport inside the web page class and say, okay, if you, let's go back to the class, if you do not provide a transport, then we can use it like this. So if the transport is not provided, if the constructor doesn't have the required argument, then the default one is this. If we do it like that, we basically get rid of, we just basically pre-configure, we teach our class how to pre-configure itself if the configuration is not provided. If the transport is not provided, then the class knows how to configure itself with the default parameter, with the default encapsulated property. In that case, we just do it like this. We don't need any HTTP. We just call it here and here. So more constructors make our code less verbose and helps us to get rid of code duplication. So we basically make our class smarter in terms of how pre-configured it can be. And look at this, for example. If we provide first and second is an instance of, for example, I don't know, URI class, and the web page accepts only the string object, an object of class string, then we have to do this toString and then toString here. This is an obvious code duplication. So we convert, we basically, in order to satisfy this class, we have to convert an object of class, for example, I don't know. So in order to convert, we need to call this toString 2 times, and this is definitely a code duplication. So we do it twice, which is not really, that would be way more convenient to teach our object, to teach our class how to accept an instance of class URI, not only just a string. So that's the second idea which I wanted to explain, that in order to make that it's really good to have many constructors in a class you design. But at the same time, we're not going to discuss it today, but at the same time, it's really good to have as little methods, as less methods as possible. So a perfect class would look like, I don't know, 10 constructors and just 1-2 methods. That would be a perfect design for a class. The more constructors you have and the less methods you have, the better is your design. So try to keep the amount of methods as short as possible, preferably less than 4, like 2, 3, maybe 4 methods in a class. That's the perfect class. And then many constructors, 10, 15, whatever. It's up to you. It's up to your creativity. But the more constructors you give to me as a user, the more reusable, the more flexible is the usage of your class. But at the same time, keep the number of methods to as low as possible. So that's how a perfectly designed class should look like. A few encapsulated properties, then many constructors, and then just 1 or 2 methods. That gives a real flexibility in object-oriented programming and makes your classes really like easy to be used and easy to maintain. The idea number 3. Idea number 3 sounds like only one constructor has to be a primary constructor, and all the rest, all other constructors, all of them must be secondary. So in this example, it's not done like that. So we need to refactor it. So this is going to be our primary constructor because it is this is going to be the primary constructor. It just accepts 2 arguments and immediately directly just encapsulates them. No new operators, no modifications to them, just encapsulate them. This is the primary one. And all other constructors must be secondary. So they have to look like this. So they all have to call the primary constructor, all of them. they shouldn't encapsulate themselves. They should call the constructor, which is defined at the end of the list. That's how it should be. And even this is not the last step. So you see here that we look at this. We call address to string, and then we have the duplication here. So this one, this line, they're duplicated. And okay, we probably needed the default one should be here. That's the default one. And then we have the duplication. So we write this code 1, 2, 3 times. That's wrong. So we should do it differently. We should say that, okay, this is the address. We take this out. If the string is if only the string is provided, then we do that, and then we call like this. So here, this is a secondary constructor. The URI, the instance of URI is passed as an argument. Then we call another constructor. We convert this. We get the actual string value from this address, and then we convert it into a string, and then we pass it to this constructor, and then this constructor creates this object, and then this one is called. So basically 3 constructors are involved if we call, when we make this call, new URI something, then in this situation, this code actually goes through 3 constructors. The first one is this. That's the first one, which is going to be called. Then this constructor calls this one, and then this one calls this one. So we go through a chain of constructors, refining the parameters and making them look closer and closer to what the primary constructor is expecting. So the primary one expecting exactly the same types, string and HTTP, as the properties we encapsulate. So we have to make sure that all these constructors, 1, 2, 3, 1, 2, 3, 4, we have 4 secondary constructors and only 1 primary one. And all these constructors, they all start with the same line. They start with, well, in Java it looks like this. So you start with this. So you basically call another constructor. You modify a little bit the arguments, you prepare them, and then you call the primary constructor. That's how it should be. Why? Mostly because, again, to avoid code duplication and increase maintainability. So like you saw an example before, we had the code duplication, we had this stuff being duplicated everywhere, we had basically the code was longer before, and we obviously had code duplication. So if you enforce this rule everywhere, and you just remember that you may have only one constructor which actually saves the parameters, the incoming arguments, into the properties, then you will be safe and you will have as many constructors as you want, and at the same time the code will be very maintainable. Not everywhere, not everybody does it like that. I've seen many classes in open source code and open source libraries where people actually just copying. For example, somebody comes in and say, hey, how about I want another constructor which will accept the URI and the transfer. And the developer says, okay, no problem, absolutely, here you go. This is your constructor. It looks cool, right? Just like that. I just copied it, I just made a copy, I just fixed a little bit, and then we have that. But it's wrong because now we have 2 primary constructors. And why it's wrong? Because if I want to tomorrow, I put this stuff in here, for example, and then I tomorrow look at this code and somebody calls me and say, hey, we should change, we should, for example, just give you an example. For example, we should check that the address is not empty. So we should not make an object if the address actually is empty. So I'm saying, okay, no problem. The bug request, I'm saying if address is empty, I throw an exception. illegal argument exception. Looks cool, right? Address can be empty. Works for me. But hey, we forgot about that thing. So here, it's possible to provide an address which is empty. So now we need to duplicate the code. Now we need to make this copy here and then make it there. So now we have obvious code duplication. And why this happened, why this code duplication actually was created, because we have two primary constructors. If that constructor would be secondary here, and if that constructor would be designed like that, which is the right design, then if I need the address to be empty, then I just introduce this check over here, and we're safe. Because all other constructors will inevitably, no matter how you construct an object, you will inevitably have to pass this one entry point to the object. This is one entry point. This is one place where we accept your arguments and create an object. And that's why all the validations, well, we will discuss later that this is not probably the best place for the validation, but everything which you want to do on the final step of the instantiation of an object, it should happen here. Or here, it doesn't matter. But in this place, in this constructor, in the primary constructor, not in secondary ones. Secondary are just preparing arguments for the main work which is done by the primary constructor. That's the idea. And one last thing which I want to mention, the principle number 4 is that we have to try to make our constructors code-free. So, like I just showed here, this is not a good code. This is not a good approach, because this check is happening in the constructor, but it should actually happen here. It should actually be the validation and everything, and actually preparation of the data and manipulation with the objects. Everything which requires some runtime execution, some time from the computer, some execution time, should happen only in the methods of the object, not in the constructors, not in the constructor, not in the primary constructor, I would say. Here, as you see, the code exists in secondary constructors, because this is definitely an execution. So definitely the transfer from URI to string will actually take some time, and we'll do the execution. This is also, it's an execution. This is also, well, this is a construction, but okay, this is a construction. This is again an execution. So in secondary constructors, I would say that the manipulations with objects are fine, because they are basically supplementary and just helpful mechanisms which help us to avoid code duplication on this level here in the client side. So without that constructor, I would still do that. So I would still have to call this method here before I actually call page content. So say I'm saying page equals to this. This is what is called instantiation, and we call it construction, whatever. And this is execution. This is where our application is still preparing to start doing something. So we're still building and constructing the application, while here we are actually executing it. So in object-oriented programming, as far as I understand it, the construction should be separated from execution in terms of what the CPU, what the computer is actually working on. So here, the computer should be idle. The computer is not taking a lot of resources, just building and preparing the object for the final execution. And then here, most of the time is spent. So this is fast. This should be extremely fast, very fast. And this is the real time taken by the computer to execute our code. So this is slow. And this is how it should be. So this step should be very fast, and like instant, and this one actually is taking time, and this is how we wait for the computer to complete the operation. If we put our execution steps into the constructor, then we break this idea. We actually make it, we break this principle, and then the constructor and instantiation of objects, this step will become slower, and this one will become way faster. And this situation will be less less tunable, less configurable, less scalable, because it will be more difficult to understand what the problems are, to detect bugs, and at the same time it will be way more difficult to improve performance. Let me give an example in this page. Let's say I want to say, hey, this is the web page, and I want to do it like this. For example, I need the page content, and then I need the page content again. This is twice. In this example, in this design, which we have now, let's remove these guys out of here. No, we need one guy here. We need this one, and we need this one. Okay, we have basically three constructors, and you see how easily I can remove the secondary constructors as long as I keep the main one intact. So. Yeah, I want to call this page content twice. And I obviously don't want to go to the web twice. I just want to, sort of pre-cache the data. I want to keep them in memory and then, being able to retrieve it. So I don't want, this is okay. This is okay for me to be slow, but this one I expect to be fast because we already have the content. We just downloaded just, a few milliseconds ago. So I want this page to be cacheable. This is the more or less standard approach, which I think is wrong. So we can, ruin this whole class and say, okay, how about let me make a copy of it. I don't want to ruin it. That's another class. And instead of encapsulating the address and all these things, I just encapsulate the content. And then the same constructors. And then here I'm saying, okay, how about we do it like this? This data equals to transport fetch address, and then return this data. What do you think about that? The actual execution, the actual time-consuming operation is happening inside the constructor now. And it looks reasonable because, look, we don't need to encapsulate the coordinates of the page. We don't need to encapsulate the transport. We just call it immediately. And this looks like a utility function now, right? So we don't really create an object. We just use an object as a wrapper for this particular call. So the actual call is happening right here. So I make a new class web page, and immediately right here the web call is made. So HTTP request is made here. It's happening right here. And then both of them will be fast. The page content will be fast and everything will be fast. So we do the execution right inside the constructor in order to, it looks for us like we're doing it in order to optimize performance. Because look, the HTTP request will be made just once. We're not going to make it here. We're not going to make it here. We just make everything right here when we execute, when we instantiate an object. This is a totally wrong approach for a few reasons. The first one is not really object-oriented because, like I said, we don't really the object, the web page class, an instance of this class is not anymore representing a page in the web and just using a few encapsulated objects in order to find that page and retrieve that page. Instead, now it represents the piece of data. So it shouldn't be called web page. It should be called, I don't know, literally piece of data, or maybe an array of bytes. But do we really need to abstract an array of bytes, and then how many constructors we will need in order to fill this array of bytes? Okay, in this case, we fill this array of bytes from the HTTP. How about we fill it from, from a static byte array, or from a file, or from somewhere else? So we easily can turn this class, in this case, into sort of a, I don't know, God object or something. So we completely lose the idea of thinking about objects. We start thinking about procedures to be executed right where we need them. So instead of building a web page, which look at this example again. Instead of building a web page, which is actually a representer of a real page in web, and it has an address and it has a transport, and when it's needed, it can go there and retrieve the content when needed. But if it's not needed, it just stays and waits for us to call and ask for this content. So this is the right object-oriented approach. While calling everything inside the constructor completely ruins the idea of encapsulation, the coordinates, or supplementary objects which will help us to get to the real world entity, which is a web page. Instead, we just execute something right here and encapsulate the result, even though it looks more performance-wise optimized for now. But I'll explain you in a few minutes why it's not really performance optimized. So the first problem is that this is not really object-oriented way of doing things. So it shouldn't happen like that. You should not do the code execution. This is how the code should look in a primary constructor. You just encapsulate coordinates or supplementary objects, which are also sort of coordinates of where the object is. So these two things, they basically provide us the information of how to find the real object in real world, and how to, and they help us to do something with that object. But they're still objects. They're not data which we keep inside and encapsulate and like it's done here. That's the first problem. The second, about optimization, about performance. In this case, the performance, well, in this case, it's faster, definitely, because we do just HTTP request just once. But it's not controllable. It's not manageable. So this is the way it is, and we can't change it. So we can say, like, for example, I want a web page. For example, let's do this code. If something goes wrong, then I throw an exception. Look at this code. This one. In this case, no matter what, we're going to download the page, even though we don't need it. For example, we need it here, so we're trying to do something with it. So we can't reach this level, this line, but we still download the page. So the page downloading will happen immediately when we create a new instance of a page. For example, okay, you may say that, okay, why are you doing it here, but instead of doing it here? But look at this. For example, I'm saying if this page, let's say, I don't know, is local network. For example, I have this method which checks if it starts with the local host, then it's one story. If it starts with google.com, it's another story. Okay, so I'm saying if this page is local network, then something is wrong. I throw an exception. I go somewhere else, so something happens. I don't know at this level. I don't know what the page is. So I have another method of this one, which is going to do something else for me. I don't want the content yet. I will need it later, and when I need it, I want it to load for me, and it's okay for me to be slow here. It's not okay for me to be slow here, but we'll discuss it now how to resolve that. So the point is that the instantiation or construction of an object should be extremely fast. It should be instant. It shouldn't be slow. It should instantly it should instantly return an object, and an object should be passive. It should wait for the call. It just says, okay, yes, I'm ready. I know what to do. I know the coordinates of a page. I know how to retrieve the page, but that's it. I didn't touch it yet. It's just the beginning. And then we say, okay, how about we download the content? Give me the content. And then in order to make it faster, we can use some caching techniques. We can use some, there are many other, like there are many caching techniques or something, but for example, you can use annotations, or you can use some, I don't know, there are many caching libraries. So you basically create another class, which is a decorator, and you say cached web page, and it encapsulates this original page, and it encapsulates cached web page, and you give the web page here, encapsulates origin page, and then we have the same method. Well, it's going to be through interfaces and everything, but I'm cutting corners here. So that's supposed to be the method which is written, and by default it's like this. Content. This is the default, but in order to catch it, we may say, okay, let's take the primitive approach, very primitive, private. It's not really good. It's just a primitive approach, very primitive. Cache. You see, I'm using null, which is I'm not supposed to do that. But let's say, just for example, if I don't know this cache equals to null, then we do this cache, we just load it. Very primitive approach called lazy loading, and we probably need to make it synchronized. Again, don't do it like this. It's wrong. But for the sake of example, so and then we want this class, and then in this case we have this cached data. So we say, okay, in this example we take new web page, and then we decorate it with new cached web page. There you go. So we decorate the web page with the cached web page. And now it's okay if page is local network, it's fine, we throw an exception, no HTTP request made so far. And then we make page content, the execution goes slow because here we say if cache is null, the cache is really null. Then we load the cache actually from the original web page, and then we return the cache. On the second call here, page content, it will be faster, well, way faster, because the cache is not null, so we just return the cache from the cache. So now we have two classes. The first one knows nothing about caching. It just downloads the page every time we need it. The second class makes it cacheable, so it returns the same and the same again and again if it was loaded first. But now it's really flexible because, for example, I don't need this cache page. For example, I need this to happen 2 times. I need this page to be loaded once, and then something happens here. For example, I don't know, the user refreshes something or the data, or I update the database here, and then I want to return it twice. I want to load it again slow. I can't do it. So this is configurable for me now because the constructor only constructs an object. It doesn't load anything. It doesn't touch anything. It gives me the control of everything. It only happens because I don't do this stuff. I don't run the code inside the constructor. I keep the constructor code free. So there are only these assignment statements in my constructor. Only assignment. I just get arguments and I assign them there. I don't run any code there. And because I don't do that, my objects are way more flexible. Because I can control what's going on. I want them to be slow. I want them to do it every time, multiple times. I can't do that. I want to cache. I create a decorator, and I cache that stuff. I want to cache it with something more smart technique, using some, I don't know, memcache or whatever, using some files, whatever. I create my own cache decorator, and I use it. So it's all in my hands. The control is in my hands. So that's the thought number 4. So again, let me summarize. There are 4 ideas. The first idea, you don't use operator new in the constructor. That's the first thing, the first principle. Try not to do new in the primary constructor. You can use it in the secondary constructor. Well, sorry, don't do new in methods. So don't do operator new in the methods of the object. So here, new is prohibited. Totally. The new operator may exist only inside constructors, primary, secondary, whatever, but not inside the new operator may exist in secondary constructors. Yeah, not even in primary ones, in secondary constructors. That's the first principle. The second one, there should be as many constructors in an object as possible. The more constructors you have, the better for the design of an object, and the less methods. You should have 2, 3 methods and 15 constructors. That's the perfect design. The principle number 3 is that one constructor should be primary and only one. All other constructors should be secondary and should start with this. And principle number 4, constructors should be code-free. They may contain only assignment statements. That's what I wanted to say. Now we have the question and answer session. You may ask your questions. We have 20 minutes to go. So before you post your questions, I can try to answer the question which was posted on the blog, and the question was about validation. So what's the right place to validate incoming arguments? There are basically two places. We can validate inside the constructor, or we can validate in the method. And there were arguments on the blog, people saying that it's better to validate in the constructor. For example, I provide an address of a web page and it's empty. So it's obviously that this page is not legal, and there is no point of creating an object and which has an empty address of a page. And that's why we need to put this validation in the constructor, and when we trying to instantiate an object, we should get an exception when the address is empty. And I would say, I don't think so. I believe in the opposite, and I think that the validation and everything should happen, especially validation, should happen in the methods, when actual call is made to an object, when we actually need something from an object. Why is that? Well, practically speaking, it's like I just discussed, it's better for performance, because it's better for speed and everything, because we don't want to make these checks too early, because it will take the time for the computer, and it will make our instantiation and construction of objects slower, which is not what we want. We want our computer to work only when we ask it to work, not when we build the structure, not when we construct an application. When we construct an application, we just put objects together, and we want this step to be instant, to be fast. So if we do the validation on this, on this process of construction, then it's gonna, it just makes this balance wrong. So the construction will be slower, and it's bad. But there's also a philosophical reason, is that more theoretical probably, is that when you make an object and if you put the validation in the constructor, then it will be more difficult to design such an object, and it will be difficult to maintain such an object, because you don't really know. It's really difficult. It will be difficult to predict of how an object may be used in the future, in terms of what's the valid state, what's not. For example, I make a web page and an address is empty. It's not really good to get the content of a page, because there is no page, and I shouldn't be able to read this page from internet. But if you ask me whether this page, for example, I may have another method, and this method will say, for example, it will be, is this page on the local network? So a page which has no address is definitely not on the local network. So this method is perfectly safe. It can just say no, just return false. So do we need to fail at this step? I don't think so. If the parameters provided are not really illegal, we just don't care how legal or illegal they are, as long as they are objects, and these objects were constructed somewhere, and there's a transport, there's an address. So we have 2 legal objects which somebody passed to us, and we just encapsulate them. So we shouldn't break at this step. We just say no problem, let's move on. I'm a page, and I represent some page which has these coordinates. I don't care what's inside these coordinates. I'm not going to check what's in. I trust these arguments. I received 2 arguments, 2 objects, the address and the transport. I put them together. I'm not going to go deeper inside and check, hey guys, are you good for me? I kind of trust them, and I just encapsulate them. And when it's going to be time to actually go to the internet and download the page, then I will ask these two guys to provide me help. And then some of them will say, hey, I'm an empty. I'm not a real string. I'm just an empty string. And then I will say, hey, there's something wrong. But it will happen later when I really start to work with an object. Until then, I shouldn't be, touching that stuff. I shouldn't be checking them. I should trust them. That's my point, conceptually speaking. So we have one question. Let me try to answer it. So here's the question. I went through the same validation question in my head when I saw your blog. I finally put things together in my head when I realized validation is an orthogonal aspect, just like caching. Why not have validation be a decorator? If you want it, you ask. That's the perfect question. That's exactly how it should be. Yes, you're right. I didn't mention that, but you're right. So the validation is exactly like you said. It's orthogonal aspect, same as caching. So if you need caching, you put this caching there, and you create a wrapper, a decorator, which will actually cache, which will help the object to cache when it's needed. The same for validation. If you want your object to be, safer, then you just decorate it, and then it will validate whatever it is. So I would say yes, the validation may go as a decorator, but it's not always possible because because the validation works on the stuff which is already encapsulated, and if you decorate, so you can in most cases you will be able to validate arguments of methods and return values of methods, but you won't be able to validate what's passing in the constructor. So you, for example, if it's a web page in our example, then I give you the address of a page, and it is empty. So this web page object encapsulates it immediately, and then we decorate it with another object, which is called, for example, validating web page. And then we call content. So the only object which can actually check that the page is not empty is the main thing, the main web page, the core object, which does the work. So you can't validate it outside of it. So so it's not possible to get rid of validation completely. You will still have some validation inside your object. Or on the other hand, you may decorate the address. Maybe that's what you meant. So we have a web page, and then we pass an argument to it, which is an address of a page. And before passing it, we wrap it, we decorate it with called non-empty string, for example. So we have string and we have non-empty string. So we pass this decorated string into the web page, and when the web page starting to access this address, then it's going to be an exception. But the exception is going to be thrown by this non-empty string decorator, not the web page. If that's what you meant, then we're on the same page. Yes. So yeah, I think you're right. Everything can be validated. Everything can be validated by decorating. That's right. So just decorate not the web page, but the arguments which you pass there, and then they will be safe. So you create an address, which is some address, and then you decorate it with non-empty address, or address only in the public internet, or address with this particular TCP port, or address without the security information, something like that. So you can decorate and decorate and decorate, and then this big decorator, you pass it to the web page. That's a good approach. That's, I think, how it should be. We have one more question. Here it is. I agree with you, but the question is, if you need to validate arguments and methods, your program will need to validate many times the same argument. If you call this method many times, what do you think about it? Yeah, that's right. Yes, the decorating as well as cache. Well, it's the same question as the caching. So if you want to avoid validating and revalidating the arguments, then you need to invent maybe some decorator or some approach to optimize this mechanism. So for example, if we have the address, and then we decorate it with non-empty address or non-empty string, then let me think. Then we don't want to Every time somebody calls this string, we don't want to revalidate and revalidate again and again. Well, in that case, you can create, I don't know, one time, maybe a class which would be called one time, like non-empty string validated one time, something like that, which will, check the string only once and then cache the results of this validating and then not check it again. So this is the perfect fine tuning of the performance, that's my point, which is completely in your hands. So you can, if you need it, if you see that there is a bottleneck of your application in this particular class, which actually revalidating the same stuff, and you want to optimize it, you just introduce a new decorator, and the performance problem is solved, because it's completely controlled by yourself. You can control it. But if this validation is embedded everywhere and it's hard-coded in every single constructor, then you're basically in big trouble, because you need to find all the places, and then you need to modify the classes there, instead of leaving the classes intact and saying, okay, this is the primitive class which just does one thing. It just downloads the web page, or it just validates the string. It doesn't care about performance at all. It just does what it should do. It just does it slowly, in a one right way. But the class will be really small. It will be micro class. It will be easy to maintain and easy to understand how it works. And then you have multiple decorators if you need. One decorator caches something, another one validates, another one does something else, and then your object will have like 15 layers on top of it. And each layer will be really small and micro layer, which will be maintainable, easy to understand, easy to modify. And the more layers you need, the more you put on that. And then your object will be like, you will do new, like you probably saw it in one of the examples on the blog, which people say it's not really cute code, but it is. I really like how it looks when you do new and then new, and then multiple layers of this indentation layers, when you have like 10 operators new, because you create an object which is decorated 10 times. That's the perfect design, because every time you can take out of this, remove one of these layers, and the object changes its behavior. It starts to behave differently, only because you have these multiple constructors in multiple decorators. I hope I answered the question. One more. We have 5 minutes. What we should do in case we use Hibernate. His requirements: empty default constructor, and getters and setters. Should we make default constructor as second? Hibernate, yes. Not only a problem for Hibernate, there's like a few Java libraries, Java standards, for example, JAXB for XML manipulations. They also have that, so they require us to have default constructor. So the default constructor should be, I wouldn't do the primary for sure. I would say that the default constructor with no arguments is definitely a second one, and then you create the primary one for your own needs, for your for where you need this object on your own way. So the Hibernate asks you to have the default constructor, just put it there, and then create your own constructor, which is the primary one. So yes, definitely. But I would, in general, suggest to try to stay away from Hibernate. But yeah, some projects, they just have to use it because it's a big and popular library. But the way this JPA is designed, Java Persistence is designed, I think it's kind of wrong, because it's based on this. It kind of abuses the mechanism of constructing objects. It abuses the object paradigm in general. It just uses objects as, I discussed that before, it just uses objects as data structures where you just inject some data with the getters and setters. So the Hibernate use an object as a temporary structure just to move the data from a database to your code. So it's not a real object, it's not a living organism with full respect to it, which knows what to do, which works on its own. It's just a temporary data structure which is created by Hibernate, stuffed with fully injected with some data, and then you get this object and you're supposed to get this data back. So setters are coming from here, getters are coming there, and then you throw away the object. It's completely dumb data structure, which is not supposed to be in object-oriented programming. But that's what Hibernate is doing. And that's a huge mistake in Java world, this entire Java persistence. It should be done differently. There is an article on the blog which explains what's wrong with this object relational mapping in general. So I hope I answered your question. One more question is this one. How should we solve the case when there are multiple fields of the same type in a class? In this case, it would be quite difficult not to create ambiguous constructors. That's a good question. That's a good question. I really wanted to mention that, but forgot. So if you create multiple constructors, if you follow the principles I explained, and your object is big, so you have big in terms of your object encapsulate too much. If you encapsulate, for example, 5, 7, 10, or whatever properties, then it will be difficult for you to create constructors as well, because they will have multiple arguments. So you will end up with constructors of, again, 5, 7, 10 arguments, and that will be a disaster. So if your object encapsulate too much, it's a wrong design in the first place. So if you have 5 or more, maybe not 5, but more than 3 or more than 4, I would say. 3, 4, that's somewhere where you have to be. That's the amount of properties you have to have. If you have 5 or more, that's a problem in design. Just refactor the class. Make it shorter, make it smaller. So if the class has 3 or more properties, then that's a problem. If you have 3 properties and they all are of the same type, then the constructor will also have 3 arguments. But it's not going to be a big problem, I think, because, well, yeah, it will be for a user, it will be kind of difficult to understand which which argument to put where, because they're all the same type. So my answer is that if this happens, then there is something not really good with the design. So try to make your designs simpler. Try to optimize it. Try to refactor and make it, because it's not really obvious for a user in the first place, like why this class encapsulates, for example, 3 web pages. Is it like, it doesn't sound clear to me, and maybe in some example, maybe if it's a chain of web pages, if it's some logical flow of the web pages, then maybe yes. But in this case, it's better to encapsulate the collection of pages. But if you really need to encapsulate like 3 different things, and they're all of the same type, then I wouldn't call this class really easy to understand and easy to maintain. So, but you're right. It's definitely going to be ambiguous constructors. It's going to be some issues with that. So try to make your classes small. That's the whole thing of, I think, of object-oriented programming and maintainability. The smaller your classes, the less they encapsulate, the less methods they have, the better it is for everything, for maintainability, for flexibility, for reusability. So if the class is small, if it just has 2 methods, if it has 10 constructors, if it encapsulates 1 or 2 properties, that's the perfect class. Just break down your entire application into small micro classes and you'll be safe. It's difficult, I know. It's kind of changing the mentality, but it's possible. So we are used to design, like, look at this public libraries which we have everywhere. They have like hundreds of methods and 1, 2 constructors, and sometimes not even 1 constructor. It's just utility huge classes. That's how we used to think, but we need to change that. So think in terms of micro objects, small micro objects which do one thing, which expose a few methods, and which expect different scenarios of instantiating by multiple constructors. I think we're done. We have one more question. Let me try to answer it and we're done. If you avoid using primitive types, you often avoid lots of same parameters. Think about your domain. That's a good comment as well. Yeah, that's right. If you use multiple primitive types, that's right. Thanks for that. So if you need to encapsulate like 3 strings, for example, string for that, string for that, and string for that, then probably you may change this type to something else. You may call it not a string, but create a custom type for your custom situation. For example, in an example with a web page, we have the string for the address. Let's define a class called address. In this case, you will avoid the confusion in the constructors, because you will encapsulate not just 3 strings, but you will encapsulate address and then something else, and then the method, for example. So you will encapsulate something more, which is some objects of types which stay close to your domain, which stay close to your business domain. That's a good comment. So you should be as close to the business domain as possible. Don't manipulate, don't use strings or integers or doubles and floats, but instead define your own microtypes, which actually reflect what's in your domain. The more types you have, the more classes you have, the smaller they are, the better it is. That's it. Thanks for today. See you next month. Next month, the first Wednesday of the month, 11 a.m. in the morning. Thanks for listening. Bye-bye.